Good afternoon. So this presentation is about personalizing videos and personalizing recommendations. And you see the PIs listed, myself, Nuno. Nuno, are you around? I know his posters will be outside, and also Trong, and Trong's posters and his demo also will be outside. So this is a brief talk, but what I would definitely encourage is to interact with the students who are behind this work that is going on. So, how do I fast forward? There's a keyboard in front of you. Okay. So, the way we see it, there are two major trends that we anticipate in the future related to video. One is about, today videos are either linear videos or basically, even if they're on-demand videos, and I see Nuno now there, and Trong should be also in the audience. Trong is here, so if you have any questions. So there are two trends that I'm seeing. One is that videos going from linear videos and even away from on-demand videos to really personalized videos. Now, if you look at the trend of watching videos, going from looking at linearly broadcasted videos to online videos is itself in some ways personalization. This is time personalization. But what we are looking at is a trend to content personalization also. So that's one thing. Second thing is, another trend that has already been started and actually commercialized is recommendations, but personalized recommendations. And many of you might have been aware of what Netflix had floated quite some time back. So the recommendation is becoming mainstream. And that has been mostly around content. But what we also see is recommendation for advertisements, recommendation for social networking, recommendations for video caching. So their recommendations can be personalized and can proliferate various different services. Now, to enable such personalized recommendation or personalized video, what we need is understand what does a user want, what are his or her preferences. And because, as many of you might have been around when our industrial speakers were talking today, and both Chris and Amitav mentioned about some of the trends in video. And if you look at that, about 70 to 80% of the data traffic will be video. So one of our thought process here is if we can just look at what people are watching, what people are doing on the internet, mobile internet, but in terms of what people are watching, and then try to infer what their preferences are. So that's that's one of the goals of this project. Now, to do that, we need to understand how to classify videos on the fly, because as you are watching videos, we need to be able to categorize that video on the fly and then accumulate around all the videos that you have watched and come up with a model to understand what your user preferences are. So we need to develop automated scalable techniques to do this, because this has to be done real time. We are talking of millions of videos being watched at any given time. So there are two techniques we are coming up with. One is which is using the information around the video. And yes, the videos that we are talking of here are online videos. So the information around the videos is the information that you find on the web page, the contextual information. And the other technique we are coming up with is looking at information inside the video. And here what we are doing is looking at, for instance, actions. So to identify the actions, and around the actions you can classify what kind of videos you are watching. And the second technique, enabling technology, that we are working on is, given that we know what the preferences are, how can we personalize the video for you? Now, there can be various kinds of personalization techniques that one can come up with. Here we are looking at how to make the video interactive, and how to make from a particular video scene, how can you transpose to some others? And I'll elaborate on that later. So this is the overall framework we had been developing. And I had mentioned that we had started developing this in the last research review for those of you who are here. And that framework was about looking at a certain defined categories into which we need to categorize the videos, and having a set of training data. This is hundreds of thousands of videos. Having the training data in terms of online videos, how can you extract the right keywords from those videos and then feed it to a machine learning technique, SVM, for instance, and come up with contextual models for various categories of videos. And then, so this is done pre-processing. And then online, when people are watching the videos, then for that particular video that you're watching, we'll extract the contextual information, the keywords, the tags, all the information around the video. And then we'll use the contextual models to identify what is this particular video in terms of the category of the video. And as we identify the categories of videos that you're watching, we will not store any information of the video, but we will just create a dial, if you will, of your user preferences from the categories of videos that you are watching. That means, essentially we'll be keeping on listing and keeping track of what categories of videos you are watching, and based on that, we'll come up with a user preference model for yourself. So that's what we have been doing. And there are various kinds of challenges we faced in the last several months to do that. And initially, our accuracy in predicting what video is being watched was about 66%. We increased that to about 76%. And so that is one kind of work that we have been doing. Now, in doing so, one thing we realized, as we kept asking ourselves, what do we mean by categories of videos? So if you go to YouTube, if you go to ESPN, if you go to any other online site, they define categories in some way. And there's a pretty standard definition of categories: music videos, sports videos, news videos, and so on. But the problem is that for the kinds of applications that we are thinking of, those categories might not be the right categories. So for instance, if you have to do movie recommendation, as simple an example as that, then you may want to identify the videos that people are watching in terms of genres, like comedy, horror, action, and so on. So the standard definitions that you find on online video sites, music, sports, pets, automobiles, might not apply here. Similarly, for instance, if, let's say, a Sears or some other company wants to use this understanding of user preferences to come up with its own personalized advertisements. Again, knowing that someone likes sports or knowing that someone likes music might not be granular enough, might not be good enough to offer personalized advertisement, for instance, in the case of Sears. So what might be much more effective is a different kinds of categorization. Similarly, if you want to use the knowledge of what people like in terms of videos they watch to cache videos to the edge of the network, something that Chris was alluding to in his talk earlier, then you need much finer categorization. Because again, knowing that you watch ESPN might not be good enough because there are millions and millions of videos then you need to bring to the cache, right? So you need finer categorization then. So one of the things that we need to then address is that, can we make categorization of videos application specific? So given the application service provider will define what the categories are, and then the system will have to go and come up with the training videos and come up with the training models automatically. Okay, now this is a big challenge because if you look at the online videos that exist there, they are labeled by these standard categories: music, as I keep saying, sports, and so on. They are not labeled with these finer categories. So the challenge is, how can you go out to the internet and extract videos and identify automatically what categories they, map them to this application-specific categorization that you are trying to do. So what we need is an automated method to obtain, as I said, good quality training data, training videos for any kind of defined categories. And so that's what we have been doing lately. What we are trying to do is, given the given the category, and this can be any set of categories. It can be any kind of categories that is needed. How to create the automated training data, how to create the training data automatically, and such that for each of these categories, now we have a large set of videos which really belong to those categories and not falsely belong to those categories. And then after that, the entire process remains the same. So one of the ways we are thinking of doing it, or we have a prototype and we have results now, where we, given the set of categories, we use various sources in the internet to come up with related keywords. So for instance, for C1, we'll come up with some keywords K11 through K1M and so on. Now, and then the overall approach can be that we look up YouTube and all the other popular online video sites with those keywords and think that those videos belong to this category. The problem with doing that is that, for instance, if you look at, let's say, the keywords related to comedy, what come up as the most relevant are films, drama, internet movie database, English language, and so on, let's say from one of the sites that people refer to, and that is Wiki. So if I now search by these keywords, the video sites, I'll come up with videos which have nothing to do with comedy. They might be completely unrelated. So that's the challenge here. And one of the things that we are trying to do is figure out how to come up with a metric which establishes what we call training video suitability. So how can we come up with keywords such that when we look up by those keywords, the internet sites, the videos that are returned are very closely related to this particular category. And so I'll not go into the details of how we are coming up with the models, but what I would like to present in this limited time is some interesting results that we are seeing. These are very preliminary results, where what we start with is some more broader set of categories. Look at these categories. These are more broader set of categories. And if we just search, so what we are trying to do is, remind you, get to training data, good training data, so that we can do the modeling using our approach. We can train the models and then use those models to identify videos in a live situation. Now, if we use the category name, so let's say these are the categories. If we use the category name and top 5 wiki keywords, then the accuracy that we obtain in saying that, okay, so after the training is done, and now for the test data, what is the accuracy in terms of what is being categorized and what the actual category is? That accuracy we are getting is about 85%. Whereas if we use this training video suitability metric that we have come up with, then we get about 96.96% accuracy, so significant improvement in accuracy. Now, on the other hand, as we define the categories finer and finer, then what we see is that our improvements and the overall accuracy we are getting seem to go down. This is not statistically proven yet because these are new results, but it seems that for instance, if you look at this, this is like really fine categories. You'll not find this kind of categories on a YouTube site or on any kind of online site. And so when we try to classify videos being watched into these categories, so without our new technique, it's about 73%. With our new technique, it's about 77%. We are improving, but not yet as much. So obviously, we need to do more, but the initial results seem to be encouraging that indeed it's possible to define any kind of categories for any kind of applications, and then have a process, an automated process of finding out the right set of training videos, and then based on that, live categorize and with a fairly good sense of accuracy. Okay. So this is the one kind of work which is using contextual information. Now the other kind of work, as I mentioned, was getting into the video and understanding what actions the videos represent. And then based on the actions, you can categorize what kind of video it is. So here, what we are doing is we are, first of all, there are various actions. And so for each action, like let's say run this action, we are first accumulating a set of videos. And then based on those videos, we will come up with semantic models. So we'll have a library of semantic models, if you will, for these various different actions. And then the training videos, each of the training videos will process and identify all the semantic models for all the actions that can be identifiable in this video. And so for each training video, now we'll have a vector of what actions and what probabilities those actions are represented in this particular video. So now we'll have a set of training videos. And then for a test data, that is, data that is, or videos that are being watched, then what we'll use is, we'll try to identify, we'll build a classifier based on those training videos in the normal way, and then use the classifier to identify which actions are present in a test video. So we obtained fairly good results using the semantic representation technique, and with much, much less dimensionality than if you had just used a plain bag of words kind of technique, where we were extracting a lot of low-level features. So this results was showing that using it is possible to identify actions, build semantic models, and based on those semantic models, it's possible to classify videos with a fairly good sense of accuracy. Now the problem is that if you look at many of the videos and many of the actions in the videos, the action might be identifiable by not just the temporal information that is associated with the action, but by maybe the scene, or some other objects around the action. For instance, if you may look at this video, and if let's say the actions are, let's say, answering phones or driving, videos which represent this action driving might also be associated with a steering wheel, and so a classifier might be able to identify this action not by the action itself, but by the associated object of a steering wheel. Similarly, if you look at the Olympic set that I had referred to the results from, most of the actions can be correlated with the scene itself, the background itself. So what that means is that we need to do something more than identify these kind of videos where the actions might be identifiable by the background scenes and things like that. So what we have been doing is developing data sets which represent, which are neutral to the background. So for instance, if you look at this data set is about diving actions and various kinds of diving actions, and all the scenes, all the backgrounds, all the other objects are the same. So we are developing these kind of data sets so that we can essentially identify much finer actions. And if I may just take one more minute. So the other work that we have been doing very successfully is once we have understanding of preferences, how can we make videos interactive and personalized? And one of the kind of personalization that we are looking at is, I'll actually refer to this slide. So for instance, we have this image and this video, and if we can extract this object and composite it on a new background. So this background might be personalized to your needs. There can be various examples we can come up with. So the challenge here is that how to extract objects, and one of the big challenges of extracting objects accurately is how to calculate the depth map. Now there are existing techniques of coming up with depth maps, but those techniques have their deficiencies in terms of the errors and so on. So one of the things that Professor Nguyen is, for instance, doing is coming up with much better depth extraction techniques, depth map techniques, where the depth maps that are extracted can be downsampled very significantly. So for instance, for this video sequence, we can extract a depth map which is 9x less resolution, that means 81x less computationally intensive, and also 81x less bits needed, with much lower error than the existing techniques. So this is a drive towards doing personalization by extracting depth maps, extracting objects at much lower cost, both computational cost as well as the bits needed. And these were some of the results that I quickly presented. Thank you, Larry.
Thank you, Sujit.
Thanks.